there's a cake for you, and that cake is coming from chemistry. A cake for you that is coming from chemistry, and that's the cake from solubility. Let's look at this cake again. The solubility of potassium hydrogen thiazocarbonate is 0.4 mole per dm³ at room temperature. Calculate the mass of potassium thiazocarbonate in 100 cm³ of the solution. If potassium is 39, hydrogen is 1, carbon is 12, and oxygen is 16. So we are giving a chemistry cake to enjoy. Now, first of all, we ask ourselves, this is a solubility question. And a solubility, we know that solubility has an expression. The first basic expression for solubility is mole divided by volume. Now, this expression is used, the mole divided by volume, which is used when the volume is in dm³. When the volume is in dm³, we use mole divided by 2. But when the volume is in cm³, we use mole times 1000 divided by volume. So these are the two basic expressions in the study of solubility. Now, for us to know the one to use in both of them, we must now ask ourselves, what is our volume? So let's take note of our quantity. Now, in the question, we are given the solubility of potassium hydrogen thiazocarbonate is 0.4 mole per dm³. So in this question, I've already been given solubility. Solubility has been given to me. So if I have my solution, solubility X, so 0.4 mole per dm³. That's solubility that has been given to me. Now, the next thing in the question, at room temperature, calculate the mass. So this question, I'm looking for one thing, the mass. So the mass of the substance, the mass of the solution, that's this solution. That's the mass that I'm looking for. Now, in 100 cm³. Now, the volume in this question is 100 cm³. So volume is 100 cm³. The volume is not in dm³. The volume is in cm³. So if we have known that, we know that our solubility expression that we are using is actually what? Solubility equals to mole times 1000 divided by what? Volume. Because the volume is in cm³. So if I take note of that, that solubility equals to mole times 1000 divided by what? By the volume. Alright. Now, in this question, I'm not looking for the mole. I'm looking for the mass. And I've already been given the solubility and also been given the volume. Volume is 100 and solubility is 0.4. Right. Now, why will I find the mole, first of all? Because I know there's a relationship between the mole, the mass, and the molar mass. And what is that relationship? The relationship between the mole, the mass, and the molar mass is giving us mole equals to what? Mass divided by what? Molar mass. Mole equals to mass divided by molar mass. That's the relationship between the what? Between the mole, the mass, and the what? And the molar mass. So if I take note of that I know that mole is equals to mass divided by what? By molar mass. So if I can find the mole, I can then find the mass. Now, the first thing to do now is to find the mole. Now, what's our solubility if we apply this expression? The solubility is already 0.4, so I have 0.4. What's the mole? We are looking for it, so it remains a constant n times 1000 still remains 1000 divided. What is the volume? The volume is already what? 100, so it's already 100. So 0 can cancel 0. This is now mathematics. So I have 0.4 equals to n times 10 divided by 1. Now, n times 10 is already 10n. So I have 0.4 equals to 10n. Divide both sides with the coefficients of the unknown. That's 10. Divide both sides with 10. 10 cancel 10. And when 10 cancel 10, what will be n value? The mole will now be equals to what? 0.4 divided by 10. You should be giving me 0.0 0.04 as the mole. The mole is 0.04. Now, we get back to our what? Our expression that says that mole is equals to mass divided by what? Molar mass. Now, the mass is what I'm looking for based on the question. Now, I need to find the molar mass. I've already gotten the mole as 0.04, right? Now, let's find the molar mass. That's the next thing. Now, what is the molar mass now? The molar mass of the solution. And what is the solution? The solution is potassium hydrogen trichlorocarbonate. The molar mass of potassium hydrogen trichlorocarbonate can be gotten by adding all the atomic masses, together. And at a case we have the molecular mass, we multiply it with the mole given. Adding all the atomic masses together and then multiplying it with any given mole. Now, at this case, I see oxygen. I multiply the atomic mass with 3 mole there. And so the atomic mass of potassium is 39. Plus atomic mass of hydrogen is 1. Atomic mass of carbon is 12 plus 12 plus atomic mass of oxygen is 16 times what? Times 3. Times 3. Of oxygen is 16 times 3 plus 16 times 3. Now this will give me 40 plus 12 plus this 16 times 3 will give me 48. And when I add everything, I'll be having 100 as the what? As the molar mass. 100 is the molar mass. Now, the mole is already 0.04. I'm looking for the mass. So therefore, I know that mole is 0.04 equals to the mass is what I'm looking for based on the question. So mass divided by what is now the molar mass? We have gotten it as what? As 100. So 100. What will I do now? Cross multiply. Cross multiply. And when I cross multiply, I'll be adding that mass is equals to 0.04 times 100. I have 0.04. We multiply what? 100. So we multiply 100. And when that happens, the final answer will now be that mass is equals to 0.04 times 100, giving me 4 grams. So the mass is 4 grams.